In this real-life example, a client wants a rectangular section fenced off with a divider. As the engineers, we have been supplied with 96 metres of fencing. The client wants the fence to enclose the biggest area possible. In this case, we are going to use differentiation to achieve this goal. This here is the fencing. We've got a section closed off with a divider down the middle. This is the wall, and the area equals the length times the width. So we've got width here and length here. As you can see, these two parts are also width. For the perimeter, we have L here plus 3W. The first step is to get L in terms of W. Which equals 96 minus 3W. Then we can sub this into the area formula, which becomes L, which is now 96 minus 3W, all times by W. And then expanding this out, we get area equals minus 3W squared plus 96W. The next step is to differentiate with respect to W. So A dash equals minus 6W plus 96. Now, when the first derivative equals 0, that's when we have our stationary points. So we'll go ahead and solve for 0. So W equals 96 over 6, which equals 16. The next step is to find the second derivative. So A double dash equals minus 6. Now the second derivative will tell us whether this is a maximum or minimum stationary point, or a point of inflection. In this case, minus 6 is less than 0, and therefore it is a maximum. So in this case, the maximum area we can make will occur when W equals 16. The next step is to sub this back into the perimeter equation to find L. So we have this gives L to equal 48. Now we can sub the length back into the area equation to find out the maximum area, which equals 48 times 16. And this gives the total area of 768 meters squared.